Hey everyone. Now I recently set up an LACP link between my server and the switch. So I've got two network interfaces on the server that go to two network interfaces on the switch. And I thought I might do a video on how to set one of these up and go through it with some packet captures to show you what it's all about. So I'm going to set up another one on my other computer. Just briefly, I've got 4 network outlets here that go to the switch, and it's the top 2 that go to the back of this server, which I'll show you now. Okay, so at the back of the server, you can see I've got the dual NIC card there. And the way I had it set up, I just had one running most of my VLANs and just generic stuff, and the other one was the VLAN for video, so it was constantly putting stuff out. But now they're linked together as an LACP link, so I'll go through that now on the other computer. Okay, I'm just starting the computer up now. And what I've currently got on this computer is just the single onboard NIC. And what I'm going to do is just plug this extra one in here and set the 2 up together as an LACP link to the switch. So I'll do that now. Actually, what I'll do is I'll show you on LibreNMS, my network monitoring system, what those interfaces have been doing on the server for the last day or so. So here you can see my interfaces on that server. And what I've got here are the 2 original interfaces, this ENP5SO, ENP6SO. And what I've done is I've joined them together as an LACP link, which I'll get to, which becomes the bond 0 interface, okay? And all the dots after it you see here are just VLANs that I've got running on it. But the main thing to know is I'm using the bond 0 interface as the LACP link itself, which consists of those 2 physical interfaces. So if I look at the bond interface over the last day, now you can see here that it says the port speed is 2 gigabits a second. That might be a bit misleading to make you think that you can send 2 gigabits a second of data through. You can, but not per stream. So if you've got an application sending some sort of stream, some sort of network traffic out of the server to anywhere, it'll only use one of those particular links at one time. But the next data stream for whatever application might use the other one. So overall, you've got 2 gig a second. But you can't just run one application with one data stream at 2 gig a second. So keep that in mind. So anyway, together, we've got this 2 gig a second link. So if you have a look at the blue stuff here, the traffic coming out of it. Now I've got a lot of video coming out of it constantly. Okay, so that's why there's about 100 meg worth of traffic constantly coming out of that server. And you should see it somewhere here. Generally 100 meg-ish, right? If I now go to one of the interfaces individually, you can see it there. The output from that is about 58 here, it's saying. And of course, the port speed is 1 gig. And if I go to the other one, you'll see the rest that would add up to 100. So those 2 together would add up to the 100 or so that we saw back here on the bond link. So what it's done is split that traffic and balanced it out roughly over the 2 links there. And the idea is, if one of those links goes down, all the traffic will then go out the other one, but it gives me some redundancy, but it does give me some extra throughput. Like if I had one link swamped out at, I don't know, 800 meg a second from one application, I've still got the other link for some other stuff. Not that I really use that high bit rate, but that's the idea of it. So what I'm going to do now is I'm going to run Iperf, which just tests network throughput. And remember, I've still only got one link down here on this thing, so this is only 1 gigabit on this computer. But I'll demonstrate through Iperf how the traffic flows. So on the server, I'll go Iperf 3, and it's server and port 1234. And I'll set up another one on a different port, server and port 1235. So on this client here, I'm going to go Iperf, make it a client to the server and port 1234. And let's see what I'm getting. About 900-ish megabits a second. That's about what you expect. Okay, so that's 900 there. Beautiful. If I do that over here as well, so Iperf 3 client of the server, and on this time it's 1235, so I'm running basically to this server up here. Same thing, we're going to see the same thing initially, so 900. But if I start this at the same time while that's running, see how this one dropped right down? Now it's down to 500. And this is pretty low. When that one finishes, this one will crank back up to 900-ish. So there's nothing special about that. That's expected because I've only got the 1 gigabit link on this desktop. So what I'm going to do is I'm going to shut this thing down, put this thing in, and set it up, and see what happens then. The computer's actually bolted to the back of this desk, behind it, so it's out of the way. So it's actually back there, so I'm just going to pull that out. Now, as I've mentioned before, I use 1 million USB devices here, so that's why I've got the 2 USB cards, but I'm going to have to take one of those out, and I'll give it a clean up while I'm here. You can see all that crap in the fan there, so I'm going to try and blow some of it out with this. This is just air. USB card, and I'll stick my network card in. Got some shit there. Now obviously under the desk I've got 2 network outlets available here, so they're the 2 that are going to go in, but I'll just plug one in initially while I do the config. Okay, so it's back up and running, and as I said, I've just plugged one in at the moment, so you can see this one's up here. That's the original. So I've got ENP3SO and ENP4SO. So the first thing I've got to do is install ifnslave. So apt-get install ifnslave. That lets me make a bonded link. So enslave bond. So there, that's installed. Secondly, I have to, in my network interfaces, so here's the interface, it's all pretty much automatic. Now I'm going to modify that and set up this bond link. So when I put some config in here for that ENP3SO, that'll take over what the network manager was doing locally here. So this will override that. So I'm just going to do interface ENP3SO inet manual. That's to not give it an IP address at all. And the next one, the same thing. Auto ENP4SO interface ENP4SO inet manual. Okay. So now I set up the bond interface. It's pretty simple, bond 0. Interface bond 0, inet, I'll make it DHCP for this. So it'll get its address from DHCP. Now, bond slaves, ENP3SO and ENP4SO. And that's it. Now the bond mode, at a 2.3 AD. And that should be it. So what I will do is I'll reboot the system once I save this screen grab and see what happens. Okay, that's this end done, but I have to do the config at the switch, so I'll just connect to the switch. So here we go, when I get there, and I'm using a 6300 as my switch. So what I'll do firstly is show int brief include backroom, which is where I am, and I've got 3 interfaces in here. That one's the one on the wall, so don't worry about that one. It's these 2 that I'm talking about. So the one that's up is the one that I'm running off here, and this is the one I'm about to plug in. So interfaces 12 and 14 are where I want this lag link. So I'll set it up. First of all, I'll define the lag interface. Now I'll call it lag 2 because I've already got lag 1 on the server end. So no shutdown, no routing, VLAN, active access 1, sorry. And LACP mode active. Now I'll come back to that and I'll disable it and I'll show you what goes on if you do that. So anyway, that's the lag link set up. So next thing on those interfaces, what is it? 1, 1 and 12. I'll just set that up as lag 2. And interface, well, the other one was 14. Set that up as lag 2. And that has disabled my connectivity, which I expected because I don't have a lag link set up here. So now what I'll do is I'll just reboot this machine and plug that cable in and see what happens. All right, why didn't anyone tell me that I wrote bone instead of bond? Let's try that again. Okay, that's better. It's up and running now. Beautiful. So if I look at the IP link, you can see I've got a bond interface here now. So I'll go to the switch again. Show in brief, include backroom. It was the first 2, so 12 and 14. But what I'll do is I'll show that lag link. So show lag 2. You can see that it's up here with 2 gig. Now what I'll do now, but I'll spare you the video, is I've just gone underneath and pulled one of the cables out. So on the switch, if I do that again, you see it now says 1 gig. Plug the thing back in, and it should say 2 gig when it gets around to it. When it gets around to it. Okay, a bit of fault finding. It's not coming back as 2 gig. And I think I know why, because I've got a dodgy cable. So if I just look at the D message, you see, look at that. It only came back as 100 meg. They have to be the same speed for that to work. So let me just fuck around with my dodgy socket here. gig on that. So it should be back. Okay, 2 gig. Beautiful. All right, now I'll show you that test that I did before with Iperf running. But keep in mind, this is running still from the server to here for both sessions. So I've got, as I said, just running on one particular port over here and one over here, still on the server. So when I run the first one, you can see we'll get up to that 900 meg like we did before. But when I run the second one, you see it still goes down like it did before. And you think, well, what's going on? Well, the reason is when traffic goes through that bond interface, the LACP interface, it doesn't share equally among the two of them. It picks one of the paths to go through. And on the switch config, I'll just show you here, show lag 2, you can see that the hashing algorithm is layer 3 source and destination. Now the layer 3 source and destination for those sessions were exactly the same. So they would have, whatever link they picked, they would have both gone down that one. So what I'll do instead, I'll just clear that. I'll have the first one on the server like I did before. But this second one, instead of being on the server, I'll do it from the piano. So I'll start it on a different host out there. Still just a 1 gig link on that. So I'll start the server one, and you'll see I'll get that 900 meg there. And now I'll go to the piano while that's still running, and you can see that now I'm getting 900 meg there as well. So because that's a different source and destination address for that session, it's gone, we'll send that one down this track. So you can see there, I've now got aggregate link, and that's what the lag stands for. So I've got the aggregate link of 2 gig coming to this machine. I just wanted to point out that it's not equally split and you just get this 2 gigabit pipe. It's just, you do get 2 gigabit overall, but not per session. So that's something to keep in mind. Okay, what I've got here is a packet capture I did on the server on each NIC. So there's NIC 1 and there's NIC 2. And if I just go to the server and show you IP link grep ENP, and just show one after, you see the one NIC's got CB and the other is CC. Okay, so here you can see, I'll just look at the Realtek end, which is the server, not the switch, which is the Aruba. You can see that I've got CB on one and CC on the other as the source address for these packets coming out. But if you have a look in the actual protocol, if I just expand that out, what you'll see is you have this active system ID and it's CB on both of them. So it's one that's acting as the active. So that speaks to the other end. But this wouldn't have worked if I didn't set the Aruba end up to be active. Like if I show you the switch config again, you can see that it is aggregate mode active. So the switch is sending out these LACP frames here, and once they do that, then this computer sees them. But what might happen is you might have some misconfiguration where you've got sort of half a link working and you've got traffic that goes to one IP address but not to another, and it might throw you out. It's because it's half there but not really there. So I just make it active on the switch, and then once those, the things that I showed you in Wireshark, once they start coming through from the switch, the host here will see that and it'll know it's part of the lag then and bring it up as 2 gig. So back on the server, you can see I had some other interfaces here, the Bond 100, 154, these are different VLANs. So I'll just quickly show you the setup for them. So what I've done on the server is I've brought those two interfaces up like I did before, just bring them up manually so they don't get an IP address. Then I create the LACP Bond 0 interface, and those adapters are part of it. Now once that's done, I make a bridge interface. Okay, so I make a bridge interface, and the bridge port I assign that Bond 0 that I just made here. And from then on, I just make another Bond interface with .4 to give it a VLAN, and then I do the same kind of thing I did up here with the bridge. I make a bridge interface from it with Bond 04 as the port. Same for VLAN 50 and so on. And the reason I've got them there is because I've got different VMs running on that server out there, and they use different VLANs, but I can still pass them through as VLANs through the LACP link to the switch. All right, so that's what I've been up to, just setting up some Bond links around here. And as always, if you want to know how things work, do packet captures and just look at them. So that's what I do. Anyway, do what you want. Till next time, take it easy, if you want.